Hey everyone, welcome to Simulation, Optimization, or Digital Twin. This is the supply chain edition. This is the rapid fire game where we test how well you know the difference between these three powerful tools. I'll describe a real-world scenario and SimWell partner Jon Santavy will reveal the right approach each of these tools plays in building better decision intelligence. Hey, let's get simulating. You need to plan the most efficient route for a truck that stops at 12 stores across 3 regions while minimizing both time and cost. What is this? Simulation, optimization, or digital twin?
Great question. This one's textbook optimization. You got fixed constraints, 12 stops, multiple regions, and you're trying to find the most efficient route. Optimization isn't about guessing, it's about computing the best possible move quickly. When you need precision and speed to guide action, that's decision intelligence in motion.
You're trying to understand why trucks are backing up at your DC gates and how dock scheduling changes would affect yard congestion.
Simulation lets us see how delays ripple through a yard, where the real bottlenecks are, and how tweaks to the schedule actually play out. That's the power of simulation. We're not just crunching numbers, we're pushing them through a defined process that gives us visibility into the behavior of a system rather than just numbers.
You've just built a simulation model of your warehouse network, and it's updated daily with current inventory and order data. It helps you evaluate where to move stock, how to respond to shifting demand, and what actions to take this week. What is this?
This is a digital twin. These are often designed for tactical planning or operational planning, and you're feeding today's data into a simulation that understands how your system behaves. That gives you a powerful planning tool to test scenarios, balance inventory, and make better network decisions day by day. It's a smarter way to run operations, grounded in process and guided by data.
You're deciding whether to shift to regional fulfillment orders by testing how different order volumes impact shipping times and cost.
Now, this is a trick question. This is where simulation and optimization team up. Optimization gives you the best case design. It answers the question, how many fulfillment centers do we need and where should they be located? The goal for this is often to determine the lowest cost configuration that meets service level targets. However, that works best under static or average conditions, which few industries are working through average conditions today. But simulation stress tests those decisions. It lets you see how your strategy performs when demand spikes or delays stack up. That's real-world planning. It's not just finding the best design, it's making sure it works in the real world.
We're trying to set the right safety stock levels across a 4-tier supply network to meet 95% service levels while minimizing holding costs.
This starts with optimization. You're solving for the right safety stock levels to hit service targets while keeping costs in check. But assumptions matter. That's why we use simulation to validate the plan. It shows how that policy plays out over time across multiple tiers with real-world variability baked in. When you combine both, you're not just designing a policy, you're proving it'll work. You're stress testing it. That's decision intelligence at its best.
Got all of them, right? Well, guess what? You're officially smarter than the average spreadsheet. These aren't just buzzwords, they're the foundation of decision intelligence. Thanks for playing Simulation, Optimization, or Digital Twin, Supply Chain Edition. To learn more, visit simwell.io.